Anyway, I probably shouldn't be showing my emails either, right? If you go to github.okarm/algorithms, you'll see this stuff. And you'll see this stuff. I should have printed it and brought it, but. So, let's start looking at what a midterm could look like. I really like that one. I could ask any of the things. Like, right, the assignments are also kind of fair game and ideas of what could be, except that many times the assignments are too complicated, right? It's something that you do over a week rather than over 10 minutes. So, but this one is probably fairly easy to do, right? Sort the following functions in ascending order of growth. Oh, F1, F2, 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 and F2. Sorry. I will eventually fix it or not. So.
Do you want us to answer it out loud?
Yes.
Ah, okay. First one is n times log n.
That's the lowest one, right?
Yes.
Then
n to the 1.5.
n to the 1.5.
N squared. 2 to the
Squared.
n. 3 to the n.
2 to the n and 3 to the n, right?
Do we have to write anything on top of that? Like if we're answering this on the test, or do we just like list them out?
List them out in the
Okay.
right order. Yeah. A blah is a connected, undirected graph with no cycles. What is blah? Good. The best sorting algorithm that uses comparisons runs in order of what time?
Sorting out.
In log n.
Here.
N log n, right? Why is it that uses comparison important?
Because it has to go through everything at least once.
Because there is a bunch of algorithms that sort of cheat, but that sort of are considered to be linear, right?
Okay.
Like, what's the, not quicksort. Quicksort is n log n and uses comparisons. The one that sorts into buckets,
Buckets.
Hash sort?
probably
Radix?
bucket sort. It's radix sort.
Radix sort.
Radix sort. They cheat by not telling you that the number of digits, right, is log of n, unless you have tons of repetition. But officially in the literature, they are considered sorting in linear time with radix sort. Linear on the length, right? There is a constant, which is the length of the longest string.
I'm sorry, can you repeat number 2 again? I couldn't hear. Is it connected and correct? Acyclic?
Yes.
Okay.
Undirected, no, what's the answer? Oh, what do you mean? No, you have to say it now. Say it loud.
A Christmas.
Yeah, Christmas.
Tree?
Yeah,
Okay.
a tree,
Christmas
not
tree is
Christmas.
Sure, oh, yeah, I was like, what? Yeah, true, okay.
It's a tree, right? It's a graph. It is connected and it has no cycles.
Okay, yes, all right, understood.
The worst case for insertion in the hash table runs in order of what time? Okay. Now we got every possibility. Who said n squared? Does insertion ever take order of n squared?
Oh.
No, right? What's the worst that could happen?
Linear.
Linear. When? The table is full, right? And we need to grow it. The hash table is full and we need to add more cells, so we need to copy the whole thing, right? Now, the default or the amortized cost, the average cost is order of 1. Because that happens in very few occasions. So over all the possible insertions, right? Over all the insertions, it averages to 1 or to order of 1 to a constant time, but you may hit the bad thing and get an order of n for one insertion. So if I had said average or amortized time, it would have been order of 1, right? The best case for insertion into a binary search tree runs in order of what time? Log n, right? How about the worst case? Log n too, right? Binary trees, right? Binary search trees, violent binary search trees do n log n, right? For best, worst, and whatever.
I just had a quick question about that. In the homework and also kind of here, when it says binary search tree, can we kind of, guess that it's complete and balanced?
No, but this would be, yeah, I should have said balanced, right?
Okay.
You should never assume that it is complete, but you can probably assume, I would rather you state the assumption that it is, that's on purpose, because if it closes, nobody can come in. Cool. You should probably assume that it is, normally I mean balanced, but if not, it's my fault.
Okay.
If you tell me, well, it's order of n because the tree may be unbalanced, then that would be an acceptable answer. Because I solved the right equation. Notice that balance is not necessarily complete, right? In fact, there's different definitions of balance.
Yeah, I understand that after I asked it, remembering exactly what complete was.
Yeah. But yeah, you can, yeah, I probably mean balanced most of the time. The adjacency matrix representation of a graph requires order of what memory? N squared. What is the adjacency matrix representation of a graph?
Series 0, 1.
It's a 2D array of
Yeah.
where the
Vertex by vertex, right? And the cells are the edges. Either a 0 for no edge and a 1 for an edge, or weights or whatever the heck you put in as tags for the edges, right? So it's order of n squared, right? Because we have n by n. The adjacency list representation of a graph requires order of what memory?
max n squared, minimum n.
Yeah. M plus n, right? Where m is the number of edges and n is the number of vertices, right? Because you always have one cell per vertex, so you have one list per vertex, and then inside the list you have all the places that you can reach. So m plus n or max of m and n is kind of the same thing. More important than this is that you understand those two representations, right? And this is kind of my way of asking that. I could ask it in some different ways. Given the following graph, calculate the shortest route from A to B. ACEB, yeah.
So I have a question about that one. Do you want us to explain any, like our process of figuring that out? Or, 'cause that's fairly small, we could just brute force it without.
Well,
really
here's the deal. If I ask the question wrong, it's my fault. I don't terribly mind if you explain more stuff, right?
Okay.
But for this, if you just tell me ACEB, that's good enough.
Okay.
Right? That, unless I ask you, and some of them, right? Now, given the graph above, provide a minimum spanning tree.
AC.
We're good at C.
AC, CE, EV? Same thing?
Yeah,
And you need to specify
Just take out the 5.
4 edges, right? Yeah. Take out the 8 and the 5, right? But in this case, you need to specify the edges that you're including, right? That's the minimum spanning tree. Right, so. Which algorithms can we use to calculate minimum spanning trees? Kruskal.
However you pronounce his name.
Sorry?
I got a lot of consonants.
Prim, right? Prims and Kruskals.
Was there another one that had like the word cuts in it, where you take
Well,
out the
cuts were the concepts, right? For all of them. The other one's called like edge deletion or something like that, right? So which one is which, or which one is prims?
Where you grow out, like Dijkstra's? I know one of them's like.
Dijkstra's is for shortest path.
Okay, that's my bad.
Prims, both prim and Kruskal you grow. In prims you grow vertices, so you add vertices, right? And so you may end up with actually no, yeah, you add vertices, you start with a vertex, right? And you keep adding the vertex that takes you to the edge, right? That's
The lowest cost to the particular vertex you're trying to add.
the edge with the lowest cost to any of the ones that you have added.
Okay.
So you are growing one tree, right? And Kruskals, you add edges as long as they don't add cycles.
Could we do a quick like prim and crystals on this little bitty tree just to
Yeah,
remember exactly
sure.
how that goes?
Maybe.
Maybe.
We can, I just need to figure out how. Let me figure out
We
how
have
to
a
download
whiteboard.
this thing. Download! Yeah, now I can
Oh, we can
write
activate.
stuff on top of this, not on top of this. Top of this. On top of this! Man, hate you thing. Okay.
Click on the
This
Toolbar.
guy.
Is it really?
Okay. And then choose, annotate, text, Control Apple T. Okay. So let's do prim, right? Let me see that I'm not lying to you.
We can pick a root, any root.
Pick a vertex.
Hey.
A, good. Now we are gonna add the vertex with the lowest cost to any of those guys, to any of A.
AC.
So we are gonna add C, right? So we added the edge AC. Now we are gonna add the vertex with the lowest cost to A and C, to either A or C.
E.
And then we are gonna add the vertex to the lowest cost to AC and E.
B.
B. And so we are adding, right? What we added here was AC. What we added here was CE, right? Here was EB.
So in prim, you always add the cheapest option available that's not going to a node you've already been to.
All of them, you add the cheapest option available, right? It's just how do you define option,
Okay.
right? So in prim, prim and Kruskal, Kruskal, right? Dijkstra is the one for shortest path. Kruskal, prim and Kruskal, you add the best, right? But it's just what the heck is best. So what you're adding is this. For Kruskal, you add the cheapest edge that doesn't add a loop. So the first one will add EB. So
Are we still picking
no, here you just pick the cheapest possible edge.
And
You start with the cheapest possible edge.
let's say like A to C and C to E are reversed. Well, can you still add edges if they're not growing from the one you've already added?
Yes.
Okay.
Yes.
So you
So-
can piecemeal put together your tree as
Yes.
Okay.
This one you're adding edges, so you end up, what you're growing is a forest that eventually becomes a tree.
Okay.
Let me go verify that I'm not telling you dumb things. Cream versus Crisco.
Yeah.
Yeah,
It's the way you showed
sounds
it.
right, but
Yeah, all right.
Cream's algorithm, yes, select an arbitrary node and add vertices, right? So yeah, it's just whether I'm confusing the names, right? So in Crucial we would add EB, then we would add
EC.
CE, then we would add AC. Ah!
And we're done.
Oh, and we're done. Yeah, now we got a minimum spanning tree, right? The other ones would add cycles. And then there is the deletion. And on that one, you delete the biggest edge as long as you don't disconnect your graph. So we would eliminate AB, then we would remove CB, and then we would see that removing the other ones disconnects the graph, and so we stop.
Thank you. I really
No?
feel a lot better having gone through it.
If you want, we can come up with a new graph and do another example. No? Good enough? Everybody else? You understand the algorithms? Yes? Cool. I'm gonna believe you. See it? Perfect. Now, describe an algorithm to find the connected components of a graph. How can you do that?
You could find the shortest path, or I guess you could try to find a minimum spanning tree, and then if it doesn't touch the node.
Isn't this either broad, breadth, or depth?
Yeah. Yeah, right?
Okay.
It's a modification of breadth first search, right? Or so you just pick a vertex, right? And navigate until you can't anymore, right? So by doing breadth first or depth first. Once you are done, then as you are navigating and adding to the connected component, you remove from the list of all vertices. And so then you just pick another vertex.
Seems like breadth first would be simpler because you're just expanding out. When depth first, you're going to go down and then kind of come back up, go down, and or does it? It's about the same.
Well, yes and no. Depends on what you're doing.
Right.
Depth first search has the possible advantage that you are using less memory
Okay.
because you are using only a path.
Right.
You don't need to keep the whole thing.
Expanding out.
You don't need to keep expanding out, so it's usually less memory.
Okay.
And if you're implementing it and you know that you don't have cycles, it's a lot easier to implement because you can just do simple recursive stuff.
Right.
Although nobody ever does because you never know if you have cycles. If you don't, then bless you. Bless you.
Excuse me.
Breadth and depth first are almost the same if you're doing it with queues or something like that. Breadth first has the advantage that it will work even with cycles. Depth first, you have to be more careful with cycles and with stuff like infinite graphs where you're generating as you go along. So if you think about the graph of positions in a game, we're moving a piece, right? So you don't have the graph, you are generating it as you go along. From this position, I can move these 10 pieces, which leads me to these other 10 positions, right? Depth first may get you, may never, right? May never end, whereas breadth first will be guaranteed to end. Name and briefly describe one of the optimal greedy algorithms we studied. They could ask you also individually, right? Like, given a set of jobs, find, right? The schedule that minimizes the total wait time or something like that, right? Or the number of jobs that wait, or maximum wait, or those.
Could we use the change problem?
You could, yeah, sure. Why not? Which ones could you describe? How many can you describe?
You can put bonus for describing more.
No.
Nah.
No, in fact, there is 4 of you and 1 of me. So I am very adamant about only grade the first answer, right? And I don't even look at the rest, just scratch it, don't even read it, right? Because if not, I'll be tempted to, right? Like if the first one was wrong, but the second one is okay, I'll be tempted to give you points, but that will encourage bad behavior.
So you have a greedy algorithm for grading.
Yes, I only grade the first. I only grade the first answer. Never look at anything else. I am not a neat freak. I'm kind of the reverse. I'm a slob, so it is perfectly okay for you to scratch stuff. I would much rather you actually scratch this stuff so I cannot read it, than try to neatly like write a square around it and tell me please don't read this or something like that, because that has more chances of me getting confused. I would rather you just my stuff. Oh, and another thing, I will probably actually write it on the test. I can only grade what I can read. I will make every effort, but I would strongly recommend not writing in cursive. Don't curse at me. Depending on, I know that this may be a pain, depending on when and where you went to school, people either trained you in cursive or not. I skip cursive. I'm actually not really well trained in cursive. I cannot write in cursive to save my life. I can usually read cursive, but it has to be neat. So if you combine that I'm not great at cursive with the fact that people tend to have horrible cursive, then I will not be able to read your stuff. And if I'm not able to read your stuff, I will just not count it, right? It's not there. So describe the coin changing algorithm. Go.
Keep picking the highest value coin until you need to give less change than the highest value coin can do.
Cool. Does it work in all cases?
For American currency.
Yes, for American currency, right?
Because we're greedy.
Because actually it probably works. I don't know if there's other countries where it doesn't work.
I think the book did say there are other countries where it doesn't work.
Yeah, I know that it works for Mexican currency too, but I have no clue what other people do. The British used to have really weird currencies.
They do. I live there.
Do they still do? They don't anymore, right? They just say a pence is now 1/100 of a pound, and that's it.
Yeah, but they still like we have what, the penny, nickel, dime, quarters. We have 4. They have like 8.
Oh.
So if like my first few weeks of living there, I had a ton of change because I'd have a line behind me. You know, I'm like screw it, here's a bill, and they give me more change. So my homework assignment one night was figuring out what the heck this change was. So I started spending.
So you can speak another language, British.
British English. Yeah, I had a couple embarrassing incidents. So, pants means underwear there, so just
Cool. What other greedy algorithm we studied? What other greedy algorithm for work?
Wasn't there the job one you talked about where it's like and scheduling classrooms for particular events using the earliest starting time?
Yes.
I think.
Go review all of those guys, right? Name and briefly describe one of the optimal algorithms for finding an MST. Anyone finding street?
Did we just go?
Yes, we just did, right? 13. Name and briefly describe one of the divide and conquer algorithms we studied. Remember at least one. Ah, merge sort. Everybody will remember merge sort, right?
Finding a median value from two databases.
I hated that problem.
That was one of your assignment things, right?
Yeah.
So much fun.
Swimming in a bathtub full of scissors.
Given t of n less than or equal than 2 times t of n over 2 plus c times n, the t of n is in order of what?
Yeah, we don't have to go over this. I see a 2 in there. I see two twos. So I'm thinking this is a recurrence relation.
It is a recurrence relation,
This is
right?
the
The
worst case.
recurrence relation has nothing to do with the two twos. Has to do with t of n involves t of, right, n over 2 or something like that. T of some other function of n, right?
N log n.
Is log base 2 of n?
This one is n log n.
N log n because it's n.
Could you work that out on the board for us?
Yes.
Um,
Or on
Well,
Yeah.
it's, if it's not a work it out and then it's a see it in the problem kind of thing.
No, I cannot do that. I can control Apple T.
Yeah. Shortcuts.
I am not using markers. I'm recording this thing, so if I, yeah. The easiest way is by induction. But let's see what it looks like, right? Let's expand it, right? So we end up with t of n equals 2t of n divided by 2 plus cn, right? Now let's expand that t of n divided by 2. Right? That's going to be t of n divided by 4, 2t of n divided by 4, right? Plus cn divided by 2. Right?
All right, give us a second, sir.
By the way, this is in the book. This is basically merge sort.
Yeah. I never quite got the
Yeah.
recurrence relation-y find the operating type.
It's good reinforcement.
Yes, that is the point of doing this, right? Now, oops.
Oops.
Did it just die? Yeah, it did.
Oh no. Peter couldn't handle it.
Garth Brooks.
Good stuff. Yeah, preview quit unexpectedly. I know.
You feel like a cowboy when you're coding?
Yeah. I didn't even know who Garbrook was until I went to a party of old people, older than me, and I liked it. And then they have been free on Amazon. And free is the right price. Now, t of n divided by 4, right, is going to be what? 2t of n divided by 8 plus cn over 4, right?
Sir,
Yes.
is that C n
C times
in
n.
parentheses over 4, or is that C times n over 4?
It doesn't terribly matter because it's multiplication and division.
Right, sorry.
You could.
Yeah.
But technically the second.
It's 1/2 times.
Yeah, it's the same
times
thing.
CN,
Yeah.
So
Yeah, it's the same thing. So what happens, right? What happens if we substitute this t of n, right? And substitute this, right? So we are going to end up with
2t and 2s.
this, right? Plus this, right? So we end up with 4, so t of n, and this is telescoping, equals 4t of n divided by 4, right? Ah!
Too much.
Control Shift C.
You gotta do too much.
Command Shift C.
Yay, thank you. So it's 4t of n divided by 4, right? Plus 2cn divided by 2 plus cn. It's 2t of n over 4, right? So it's going to be, sorry, 2t of n over 2. So that's going to be 2 times 2, 4t of n over 4 plus cn over 2 added and subtracted, right? So it's going to be plus cn.
What about that last CN that makes it 2CN?
Sorry?
So, I'm just.
Yeah, that would be 2cn, but, right? Yeah. We could, right?
Yeah,
But-
but I'm just. I guess what's throwing
But
me
actually
off
we
is
can't yet.
TN, your two iterations of TN are not equal.
Well, now we are going to iterate, right? Let's replace that, 4t of n over 4, right? So what's going to happen? So I'm going to end up with t of n equals, I'm going to replace t of n over 4 by this value, right? So I end up with 8 t of n divided by 8, right? Plus 4cn divided by 4, cn, plus 2cn, right? Is this correct?
Yeah. Okay. Alright.
Does this make sense? Eventually, what is going to happen?
And
That n divided by whatever, right, is going to be 1, right? And so t of 1 is 1 or something like that. It's going to be a constant, right? T of 1 is a c, right? So what happens? How many times did I add cn?
in time.
Not n, right?
Log n.
I went n, then n over 2, n over 4, n over 8, right? N over 16. So how many times?
Log base 2n.
Log n. So what's the total running time of this thing? N log n.
Does this, I remember back in calculus, we went over the idea that if you have like 1 over n, and you sum it with as the limit is approaching
Yes.
infinity, it's going to equal 1. So if you keep adding 1 over 2 to the n, as n increases, it's going to equal 1.
That depends actually. The master theorem that the book doesn't call the master theorem basically says, here's what happens when you have a formula like that, right? And you could vary this number, you could vary this number, and you can vary this stuff. So the book says something like 3 different examples, right? And the master theorem has a much more, a better, right, way. The book says 3 examples because you can get n or n log n, right? If this is c rather than cn, I think, then you end up with, log n, right? There was one there where you end up with n.
Wait, wouldn't that make it end with n? Because it's the cn that adds the constants that end up becoming log n. So by taking out the n,
You end up just log n, right?
I thought the n over 2 is what ended up expanding out into n.
That expands into, that's the log n times.
Okay.
No, you're right. That becomes n. You take away the, if it's just plus c,
Yes.
then it becomes just n, right? Did
Um,
you say that and I just was blanked out?
No, if you say plus c, you would end up c times log n. So the order would be log n. Right? Let me, you can go to the book and look at the 3 cases that they give you, which are the only ones that you're responsible to memorize. But this is the thing, the master theorem says that when you have a recursive relationship like this, right? T of n equals alpha t of n over beta plus f of n. Maybe that, we call them A and B. You get this thing, depending on the f of n, right? If you think about it, right, this is the divide part, right? How many pieces you divide it into is the b, and then, right, how many pieces you actually end up with, right? And then the f of n is how long does it take you to combine, right? And we assume that t of n equals theta of 1, so at some point in time you get to a constant time, right? And f of x relates to this exponent, log p of a. But f of n is order of n to the c, which is, c is a constant, right? You're going to end up n to the c critical, right? So you would end up with n squared or n to the half or something like that. this is right less than that, but if it's not, then that's not the case. If it's greater than oh, sorry. This is this one, right? If they are equal, if fn equals, this is less than secret. 2 is oh, you don't have, right? When it's the same critical, right? Then you're going to end up with one more log. So this is this case. It is. So if our combining was n log n, we would end up with n log squared of n. And so on. And then when you have different exponents, so if you had something like n squared or something like that, you end up with that. Which would be but it depends on these two guys too.
So if you had a merge sort where you had to check and compare two different values in what particular objects you're sorting. So let's say you're sorting an object called C. It's got two values, A and B, that you have to compare for each one. So basically, just the comparing takes, I don't know, I guess that'd be 2n. That doesn't work. I'm
No,
trying to think
but
of a
there's
way to-
for median, it's more the other way around. For calculating the median, you can do something like quicksort, right? Do you remember how quicksort works? Yes? You find a pivot that you hope that it's in the middle, right? And then you run an order of n thing that will divide the thing, put the pivot in its right place, and have everything before the pivot be less than the pivot, and everything after the pivot be more than the pivot, right? And so if your pivot is somewhere in the middle, right, then you end up with 2 halves, right? So you end up with order of n log n, right? And by the way quicksort works, actually the constants end up being lower, so it is really good in practice, although in theory it's still n log n, right? Now when you're doing median, right, you can do the same thing, but you don't need to look at both halves. You only need to look at one half, right? Does that make sense? Because the pivot would be somewhere, and you would know whether you need to look at the before or at the after half. And so that gives you actually basically 1 t of n over 2 plus f of n, right, plus cn. So the total running time is actually order of n rather than order of n squared. So that's an example with different numbers. I don't know if that's what you were looking for.
It's still a lot. Like, it's still tough. I'm not gonna say that.
Yeah. This thing is actually hard and kind of like, oh yes, I'll read it once, understand it, and then never use it again, and use Wikipedia to go plug the numbers, because that's there is a horrible algorithms book that I can't, yes, this guy.
Yeah. Is that one supposed to be horrible?
Well, it is an amazing encyclopedia. It is a horrible textbook, right? It is horrible. Like, it will put you to sleep within 5 minutes. On the other hand, it contains amazing amounts of knowledge. It is a great book to buy used and put on your bookshelf. It actually looks like you know stuff.
I used to keep one in my cubicle.
Yeah, makes you look really good, almost as good as Knut's book. But it has a great chapter on this stuff, recurrence relations and the master theorem. It's probably the best set of stuff. It's just not terribly useful to go deep into that.
Like, you don't want to read a chapter every day kind of thing out of this book. You want to keep it on your shelf when you need it.
Yes.
Okay.
Yes. And if you have a chance, we probably have it in the library. Go borrow the book and read the chapter on recurrence relations. It is a very good thing to do. I'm not forcing you to do it before this class ends. I'm definitely not torturing any of my students with this thing. It is an amazing reference. It's just not a very pedagogical book. I really, really like the titles that we are using for its pedagogy. It's usually a problem of what do I want, an encyclopedia or a textbook. I figured we wanted a textbook, but I don't know. Hopefully I won't ever teach this class again. Whoa, it's not my problem anymore. Do you see why? And the book basically does this explanation, right? It also goes to a proof by induction by showing exactly this, and it shows you the tree where you have basically this with a beautiful tree diagram.
The image of the tree clicked with me better than just the numbers. So, for me personally, I haven't yet had the light bulb moment when it comes to this, but I'll be studying.
Cool. Any other questions? No.
Sorry, I'm exhausted.
You're already tired. That's how you're gonna be on Monday. Probably.
Yeah, my wife and I actually both
Oh.
got a little bit sick last night. It wasn't too bad, but it kept me awake. So
Kind of a ridiculous question, but what other divide and conquer algorithms did you talk about that we have to know? Because I remember you talked about a lot about the math ones. Ones for multiplication, and you did for oh my gosh.
Furriers?
Merge sort. Yeah, Fourier. I'm not expecting you to remember other than the name. Some of the math ones, I expect you to hopefully remember and have a clue, right? I will not ask them by name, right? Quick sort, I expect you to have a clue. Merge sort, the median, which is in the book, right? Median one for quick sort, the quick sortish median, and that's important. That's really important for job interviews. Because you would think that the obvious algorithm for finding the median of something, right? What's the obvious algorithm for finding the median of something?
Sorting.
Sorted, right? How long does it take?
And log in.
N log n, right? Not n. So knowing that there is an algorithm for doing it in time n rather than time 7 log n is very good for job interviews. For solving some problems, usually where I need to find the median and then do something with it, right? Anything else? No? I'll give you back 15 minutes of your life.
So I have one last thing. Sorry, no. It won't be, it's not a math question. Sorry. So I know it won't be the same, but is this the kind of test we should expect come Monday? Like, I guess, what's the variance on how different the test we could see? I'm not asking, is this the test we're going to see? I'm just like, are you going to throw us word problems or something we didn't expect?
it's a valid question. I'll give you the standard answer that I would have to give you anyway, but in this case it happens to be true. I don't know. I will know on Sunday night.
Okay, that's acceptable.
But here's the deal, right? I sat for a couple of days, right, going through this stuff over and over, and these are the questions that I came up with, right? Would I come up with very different questions within the next couple of days? Probably not. On the other hand, it's not right. I've never taught this class. I've never taught, right? Normally I give you sample tests when I've taught a particular class. I'll actually give you, right? If I ever teach this class again, I'll show the actual test that I gave to the class, but I haven't done it this time.
So it took us too early.
Okay,
Yeah.
I appreciate it. I'm sorry. Just,
No.
You know,